All right, ladies and gentlemen, time to continue with Module 5 notes. We're going to be taking a look at Module 5, Lesson 17, Attributes of Parallelograms today. This one's going to look a lot like 516, where we talked about the attributes of trapezoids. We're going to go over some vocabulary to start. We're going to draw a couple parallelograms, just kind of explore what they look like, how they're different from trapezoids. But you're not going to get all the attributes today. We'll kind of go through the lesson and we'll build that out together tomorrow, or when I see you in class next. So 10 plus 5, 6, 7 more should give us 17. We'll go ahead and put that right there. And as promised, we will start with some vocabulary. Now, I've mentioned before, you're going to want to go back and look at some of your previous lessons on geometry to get some of the terms. 516 is going to have a lot of the terminology we're going to use, so I'm not going to include everything. For example, I'm not going to make you write polygon again. Hopefully you know that's a two-dimensional shape with 3 or more straight sides. I will, however, ask that you write quadrilateral again. Quadrilateral. Because it's super important you know that term. In 5th grade, the polygons we're dealing with, almost every single one of them is a quad, 4-sided polygon. A 4-sided polygon. Okay. A 4-sided shape. Not sure what that thing on the paper is, but oh well. Quadrilateral 4-sided polygon. Trapezoids are quadrilaterals. So are parallelograms. Okay. Since it's in the name, parallelograms, we want to make sure we remember what parallel means. So parallel, once again, these are lines or line segments or rays that run side by side. They run side by side. They go in the same direction usually. Well, always. They never intersect, excuse me. They never intersect. They never touch. They never cross. Okay. Let's make sure that looks like an O. Parallel, they run side by side. They never intersect. They never cross. Now, we will also be talking about consecutive and congruent again. Consecutive mostly when we're dealing with angles, but sometimes consecutive sides. Okay. These are next to each other. They're next to each other. And they touch. Now with angles, that's a little harder to kind of visualize because it may not look like the angle itself is touching. Angles themselves are touching, but usually they'll share a ray, they'll share a side. Okay? And then finally, the last one, congruent. Sorry, folks, I know I ended up making you copy most of the ones again, but it's hopefully going to help you remember. Because you need to know that congruent is just a geometric way, a mathematical way of saying the same size. The same size, saying that they're equal. Okay? Saying that they are equal. Now, keeping that vocabulary in mind, we're going to use it as we go through. We're going to explore. We're going to talk a little bit about the attributes of parallelograms. And actually, to do that, we're going to start by kind of reviewing what some of the attributes of trapezoids were. Now, when we talked about trapezoids, one of the first things we did, we kept saying, is we start with parallel lines. Okay? I can use a ruler. I'm going to use my protractor, any straight edge. And I am just going to go ahead and make two parallel lines. Okay? Now, with a trapezoid, I have some options on how I connect these lines. I can have a straight perpendicular line. I can have a straight line that goes up and down. I can have a line that goes out to the side. I can have two lines that go out to the side. I've got some options. Parallelogram, I'm a little more limited. We've got 1, 2, two parallel lines already. We have one pair of parallel lines. But with a parallelogram, the connecting lines must be parallel as well. So I'm going to go ahead, I'm going to use my protractor to help me. I'm going to trace a line here. I'm going to trace a line here. I've got some erasing to do because my original lines went out a little far. That's okay. Okay. But I'll go ahead and erase that little extra. And now, right there, but I also have this pair of parallel lines. Now, this line right here is obviously not parallel to that one. They intersect, they cross, they touch. So it's not parallel to that. That's why I can't just put a single arrow here. I don't want to put just a single arrow because I don't want to accidentally say, well, this is parallel to that. It is not. It is not. This is parallel to this. This is parallel to this. Now, in this particular parallelogram, if we look at the angles, start by looking at this one right here. This angle we're going to kind of mentally compare, is it more than or less than 90 degrees? If I put kind of an imaginary perpendicular there, then I can see it's just a little bit less than 90. So this is an acute angle. Oh, it's so adorable. It's a cute angle. Now over here, if I try to do the same thing, my height actually ends up going on the inside because this angle right here is obtuse. It's bigger than 90. Obtuse angle. Our consecutive angles on this parallel, one is acute, one is obtuse. And it's interesting, if I look up here, this one's acute. And actually, I'm going to double the line on this one because I want you to see that this one is obtuse. And those of you who have a protractor, go ahead and measure those angles. Just see if you notice anything else. We're going to do that together in class, so I'm not going to do it right now. But there's something else interesting about those angles as well. Now, trapezoids only had one pair of parallel lines. Parallelograms, well, parallels in the name, so both pairs are parallel. We've got an acute and acute, an obtuse and obtuse, but are there other options? Well, imagine if you built this out of, I don't know, toothpicks or popsicle sticks. If you took the sides and straightened them up a little bit, what would happen? What would happen? I'm going to go ahead and trace. Okay, there's some parallel sides. Some of you probably can already tell where I'm going with this. I'll go ahead and, oops, got to keep it on the screen. We'll go ahead, complete that. Now that's interesting. Two sets of parallel sides. So that seems to fit what I've been telling you about a parallelogram so far. 90 degrees here. 90 degrees here. 90. But a lot of you are probably looking at that and going, wait a minute. It's not a parallelogram, that's a rectangle. It actually looks like it might even be a square, but it's definitely a rectangle. Can it be a rectangle and a parallelogram? An interesting question. How is it different than this? Also, think 90, 90, 90, 90. 90 plus 90 is 180. Well, 90 plus 90 would be 180 down here too. 180 plus 180, that's 360. That's kind of like the trapezoid too, where if you add all of the angles together, you get 360. If you rip them off, put them together, you get a full circle. I wonder if that's true up here as well. Interesting. Now, again, we're going to explore some of those things in class, so I don't want to go too much more into it. There is one more parallelogram I'd like to draw. It's going to look pretty similar to the one up above, not exactly the same. I'm going to use my ruler this time so the thickness is a little different. Give you a little variety there. There we go. Okay. Now this particular parallelogram, again, I mentioned, should look pretty much like the first one we did. See, it's about 3 lines down. We're going to check and make sure this is parallel to that. This is slanted pretty seriously, but that's okay. So is this one. They're parallel. Looks good. I've got an acute angle here with an obtuse there, an obtuse opposite. This is acute, just like the opposite angle. Biggest reason why I want to show this, though, something we didn't practice much in class, as much as I wanted to anyway. I want to practice how we label these, how we name them. Okay? Polygons get their name from their vertices, from the points at the edge of each line segment. Usually you're picking letters. Doesn't really matter where in the alphabet you start. F, G, H, I. They're not always going to be in perfect alphabetical order either, but pretty frequently. The name of this, I know I'm kind of putting it backwards, but just for a parallelogram, you usually draw it that way. This is parallelogram F, G, H, I. It's made up from a number of sides, 4 sides. We have line segment FG, from F to G right there. FG is parallel to line segment HI. Hi. Now we talked before, I could have put IH, I could have put GF. It doesn't really matter. I usually like to put it in alphabetical order, but whatever. Okay. Over here, we've got FI, or if you put it the other way, it would be line segment IF. That's parallel to line segment GH. Okay. As we move more into graphing, this will be even more important. We touched on it a little bit, but I need to get in the habit of making sure I'm showing you this. Parallelogram FGHI. It's named based on the vertices, the points in the corners. Okay. All right. Hopefully not too stressful today for your notes. Go ahead and make sure you have this copied down. If you have any questions, we'll go over it during class. Just please, again, make sure that you're feeling good about this vocabulary. We did mention consecutive a little bit, but congruent is going to come up a lot more when we go over this. Congruent. We're going to talk about things that are congruent. You may already be noticing some things that look the same, that are congruent. All right, we'll go ahead and stop here. Thank you, ladies and gentlemen. Record those questions if you have them, and I will see you in class.